Welcome to section 6.2, factoring by grouping. So we're now going to apply what we just learned in 6.1, specifically about the greatest common factor. But there's going to be a little bit trickiness perhaps. So not trickiness in terms of trickiness, but it just takes a little bit of re-looking at something differently, if that makes any sense. Let's just do an example to kind of show how to do this. So I want to factor this polynomial that has 4 terms. So the way we're going to do this is I'm going to look and say, okay, I'm just going to look at the first 2 terms because notice there's no greatest common factor of all the terms. There's x's here, but there's no x's in the last term. These all have 2's. This has no 2's. So I can't pull anything out of these. But if I look at the first 2 terms, what is the greatest common factor of these 2? Hopefully you said it's x squared. If I pull x squared out of just the first 2 terms, what's left over? Well, notice it's x minus 2. I take this plus and it's just going to come down. What's my greatest common factor of these 2? Hopefully again you're saying, well, it's positive 2. And what do you have left over when you factor 2 out of there? Well, you get x minus 2. Now notice, look at this, I have x minus 2 in both terms, so I can factor that out. And what's left over? X squared plus 2. So I just factor this by actually using factoring by grouping, but instead of factoring the greatest common factor, but instead of trying to factor the greatest common factor of all the terms, I picked 2 at a time. And if there's 4 terms, we're going to look at pairs. If there's 6 terms, we could look at pairs or threesomes, et cetera, et cetera, et cetera. So we're just going to break them up into even groups and look for commonality. So let's look at another example. So again, I have 4 terms. Just look at the first 2 and the last 2. And ask yourself, I want you to pause the video, find the greatest common factor of each pair and factor that out of each pair. All right, so your first one, hopefully you realized if I'm going to pull a 3x. And if I do that, I'm left with 2x minus 5. The last one, again, I can pull a 2, and I'm left with 2x minus 5. Now, these had better equal the same thing inside the parentheses. If they're not, you can't go any further. But they do, so we can pull that out, and I'm left with 3x plus 2. So again, this is all about the greatest common factor, but we're just looking at smaller groups that we're looking for greatest common factor. All right, so let's do another one. I want you to try to factor this one. Go ahead and pause the video and factor this by grouping. Okay, so hopefully you work through it. You looked at the first 2 pairs and the last 2 pairs. And the first 2, one's m, the other's n. There's nothing in common there, but the 2 and the 10, I can pull out a 2, and I'm left with m plus 5n. And the next pair, I have 3 and 15. I can pull out a 3, but I can also pull a y out. So I get 3y, and you're left with m plus 5n. That's exactly what we want it to be. And so we can pull that m plus 5n out, group what's remaining, and you get 2 plus 3y. So again, we're just looking at smaller pairs. Let's do another one. I want you to factor this again by grouping. So go ahead and pause the video and try to do it. All right. Hopefully, you paired them off like that. The first one, you just only pull y. You're left with 5x plus 2. And then notice this minus. This is kind of important. I brought that minus down, which means because I want this to be a positive number inside the parentheses. So I got to pull a negative out, but that means I'm also going to pull a negative out of here. Specifically, I can only pull a negative 2 out of both terms. But if you do that, because notice negative 4 divided by negative 2 is positive 2. Hence, they both have 5x plus 2. And then you're left with y minus 2. So we can put all this together and kind of go from there to see how all this works. All right, let's try another one. Can you factor this by grouping? Go ahead and pause the video and factor it. All right, So hopefully the first two terms, you realize you can pull a 3x squared, and you're left with 7x minus 1. Last two terms, 7x, negative 7x, and plus 1 don't have anything in common, but I can pull a minus 1 out of them. If you pull a minus 1, then you're left with 7x minus 1. So again, 1 is one of those perhaps sneaky ones because it's one that we don't usually see. We're lazy. We don't like to write everything times 1, even though it's hanging in there. So we can continue going on, pull the 7x minus 1 out, and the other term is 3x squared minus 1. So just working through this, kind of be conscious that sometimes it's a negative when you're pulling things out. That's where it starts causing some troubles, and people tend to make some sign errors. So just be conscious. Again, you can check by multiplying your final answer out, and it should equal your original problem. Okay, so let's do this one. I want you to pause the video and go ahead and try this one. All right, so hopefully you group them. First two, you said I can pull out a 5, and I'm left with 7 plus a. I'm pulling out a negative because I want that. And again, I can pull out a minus a squared, and I'm left with 7 plus a, excuse me. Pull the 7 plus a out, and we get 5 minus a squared. So we can work through this layer by layer by just looking at pairs. Let's do some more examples. I want you to get really, really good at this. So notice I now have 6. So we could do multiple ways to do this, but I just want you to look at pairs. So let's look at the first pair, the second pair, and the third pair, like so. What's the greatest common factor of each pair? Go ahead and try doing this. All right, so hopefully the first pair you saw, I can pull at x squared, left with x minus 2. Second one, I'll pull out a 2x, and left with x minus 2. Okay, this is a good start. What can you pull out of the last one? Hopefully you're saying 4, and I get an x minus 2. Notice all three terms have an x minus 2. Pull that out. What's left over? Well, x squared plus 2x plus 4. So that is how we factored this 6-term polynomial by using factoring by grouping. All right, what about, here's another one. Can you again factor this by grouping? All right, hopefully again you group them. And then you said, okay, the first terms I can pull out x, and I'm left with x plus 3. I play 2, and I get x plus 3. And so you get x plus 3 times x plus 2. Now I do want to point out briefly that the very first polynomial, I could have combined terms, but that would have caused trouble in terms of how we actually went ahead and factored by grouping. So if I give you something so far in 6.2, don't combine terms, just go ahead and factor by grouping as it currently stands. This, though, will be a role in our future sections. So please keep this in mind as we continue to go forward. All right, that's a lot of examples. You feel free to do more examples. If you have questions, please let me know. Otherwise, good luck, and good luck with the homework, and I'll see you in the next lecture.